Welcome back. Welcome back. For today's lesson, we're going to get into some arithmetic with negative decimals, though. Negative decimals, not integers, but decimals, as you see right behind me. But before that, I want to shout out this ancestor, this sister that's on my chest and on my t-shirt. This is one of my favorite t-shirts. This is Rosa Parks, right? A lot of us have probably heard of Rosa Parks, right? But if you haven't, Rosa Parks was very instrumental in basically kicking off the Montgomery bus boycott, which took place in 1955 in Montgomery, Alabama. It lasted for 381 days, and it was an attempt to gain equity and equality and fair treatment on the public transportation system in the city of Montgomery, Alabama. And it started with her refusing to give up her seat on one of the local buses. All right, and Rosa Parks was also a person that worked with the NAACP very closely already. So she was already familiar with this type of work, this type of activist type work that, you know, her and many other people in the community of Montgomery, Alabama were involved in. And also, this was when Dr. Martin Luther King Jr. really started to come to fame because he was chosen to be the leader of the Montgomery bus boycott back in 1955. So many things were happening in 1955 and around this time in Montgomery, Alabama. And Miss Rosa Parks, the ancestor, rest in peace to her, was very much instrumental in these things taking place. And be on the lookout for a documentary that's going to be coming out about Miss Rosa Parks in this fall of 2022 on the Peacock Network. They're not paying me to say that, but I just wanted to put it out there so y'all could go check it out, you know. But at any rate, yeah, so I just wanted to take a moment to shout out Rosa Parks before we get into this math problem. So, this math problem, it says negative 2.8 plus negative 5.3. Now, a couple things. Whenever you see an addition sign and then a negative number, we know that we can rewrite that or we can simplify that and just make it a plain old regular subtraction problem. We know that we can do that, all right? So that's the first thing I want to do. I want to rewrite this problem. I'm going to just make it negative 2.8 minus 5.3. So think of it like this. Let's kind of like try to conceptualize this. Negative 2.8, imagine there was a 0 next to this 8. And we think about this in terms of money, right? So if there was a 0 next to this 8, this would be a negative $2.80. Or it's like saying you owe someone $2.80. This 5.3, or this negative 5.3, means that, well, you can think of this, if there was a 0 next to this 3, you can think of this as negative $5.30. So imagine you owe somebody $2.80, and then subtracting is like borrowing. Subtracting is like borrowing. So then you borrow another $5.30. The question that you're really being asked is, how much have you borrowed altogether? How much have you borrowed altogether? So what we could do actually is we could treat these like positives, at least mentally. Mentally, we could treat these like positive numbers and just add them up, all right? So I'm gonna show you how to do this manually, right? So let's say I treat this negative 2.8 like a positive 2.8. So I write the 2.8. Let's say I write them vertically, right? Stacked on top of each other. And then I write the 5.3 underneath. I draw my horizontal line, I put my plus sign, right? Now I start from the far right, all right? Now this is like the standard algorithm for adding numbers vertically. So I do the 8 plus the 3. 8 plus 3 is 11, right? But I can't go past 9 in this column, right? So, or really, I can't go past 10. 8 plus 3 is 11. I put the 1 from the ones place in 11, and I carry that 1 to the ones place. Rather, this is really the 10th place, and this is the ones place. So then I'm adding this 1 plus this 2, which is 3, 3 plus this 5, which is 8. And then I write that, and don't forget about the decimal point. When you're adding or subtracting, the decimal points line up. So if the decimal point is right here, even in your sum, your decimal point is going to be in the same place, basically. So this adds up to 8.1. But remember from the beginning, this was a negative 2.8, and this is really a negative 5.3. So instead of the answer actually being positive 8.1, the answer is actually going to be negative 8.1. Because if you borrow $2.80 and then you borrow another $5.30, altogether you have borrowed $8.10. You've borrowed because it's negative. All right, so that would be negative 8.1. All right, now let me think about, I do want to kind of talk about this a little bit, like how to do this like using like mental math without writing anything down. What I would do is this. Again, I think about it like money, right? This is $2.80, right? Or at least I visualize it that way. I visualize like 280 and I visualize that like 530, all right? I put the dollars together, $2 plus $5, that's gonna be $7. I keep that in mind, right? That's $7. The $2 plus the $5 is $7, right? And then I got 80 cents and 30 cents, right? 80 cents and 30 cents, that's gonna be $1.10. Because I know that 80 cents plus 20 cents is gonna give me $1. And I still got another 10 cents left over. So that's $1.10. So now in my mind, I already remember that I had $7 from doing the $2 plus the $5. And then I got $1.10 plus from the 80 cents and the 30 cents. So I'm doing $7 plus $1.10 is $8.10 or 8.1. But I also keep in mind that from the beginning, this was a negative and this was also subtraction. So instead of it being a positive 8.1, it's a negative 8.1. So these are just some ways that you can approach these problems. You can write it out like this, or you can also think of it in terms of using place value and doing mental math. You know what I'm saying? You can do the mental math. Now, what about with a number line though? If we had a number line, if we start at negative 2.8, right? And we're subtracting 5.3 because adding a negative is the same thing as doing subtraction. This is like a simplified form of this original expression. Subtracting 5.3, right? Subtracting 5.3 means you move to the left, right? You move to the left. You move away from 0 and away from the positive numbers. You move into the left. So I'm going 5.3 spaces. So if I went like, I'm gonna just, I don't know, I know I'm gonna end up at negative 8.1, right? I know that. I just know I'm gonna end up at negative 8.1, but I just want you to visualize, like, if you start at negative 2.8 and then you went 5.3 spaces, like if you went 5 spaces, that would be, let's see. So if this is negative 2.8, let's imagine that that's negative 3, and then negative 4, and then negative 5, and then negative 6, and then negative 7. My spacing is off, excuse me for that, right? But if I go, let's see, 1, 2, 3, 4, 5, right? This is 5, right? But I had to go 5.3 spaces. So from negative 2.8 to negative 3 is that 0.2. That's the 0.2, the difference of 0.2 or a difference of like 20 cents, right? Think about it like money. And then the difference between, actually, yeah, I could put an 8 right here. The difference between negative 8 and negative 8.1 is 0.1. So that's why we end up at negative 8.1, right? Because we got the 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, right? No, actually, no. Here's where we started. So this is 1, 2, 3, 4, 5. That's our 5 right there, right? That's our 5 right there. And then the 0.3, where does the 0.3 come from? This 0.2 in between, and then this 0.1 right here. 0.2 and 0.1 is 0.3. So you end up at 8.1. Well, really negative 8.1. That's where you end up at. You know what I'm saying? So this is just an example of like what we deal with when we're dealing with decimals. You know, when we're dealing with decimals, we could treat it like we're doing addition if we understand what's really happening. And we could either do 2.8 plus 5.3 and write it out as an addition problem, or you can think of it in terms of mental math. You can add your numbers in your ones place, which will represent dollars, and then you can add your numbers in the 10th place, which is your 8 and your 3, 8 tenths and 3 tenths, which is like saying 80 cents and 30 cents, which will give you $1.10. And then put $7 with $1.10. That's gonna be $8.10. So you wanna make this easy. You wanna make this easy, you wanna make it practical, you wanna make it make sense to you. You wanna make it relatable, you know? Money is always a good way to make it relatable because we deal with money. You know, we have to buy things, we sell things. You know, money makes, math computation very relatable. All right? So now with that in mind, and with that being said, until next time, go get some practice.